I can see Jonathan joining from Osun State. All right. Very, very, very interesting. Welcome to today's session. And Iman is saying this is first session. So we're going to be kicking up soon. And permit me to introduce our trainer properly. All right. So today we're going to be discussing on architecting low code AI solutions too. So, and the person who's going to be taking us this class is no other trainer but our amiable and amazing trainer, Mofe Akinola. Mofe Akinola is an AI engineer focused on building practical, scalable AI systems using low code and cloud native architectures. His work centers on designing intelligent automation solutions that integrates machine learning, deep learning, generative AI, and enterprise platforms to solve real business problems. He has experience in developing AI-driven systems such as multi-agent business assistants, operational analytics tool, and workflow automation perform and he also performs the integration with enterprise environments, including ERP service and service management systems. Mufe is particularly interested in bridging the gap between theoretical AI concepts and production-ready solutions that organizations can deploy efficiently. I would like us to welcome Mr. Mofe to the class today. He's going to be our trainer for today. Mr. Mofe, can you hear me, please?
Yes, I can. Good morning. It's
Good
good to be here.
morning. All right. It's good to have you.
All all right, then. Good morning again. I welcome everybody to the second class in this course, and I hope we are looking forward to learning as much as possible, as efficiently as possible. I will take us through the class, and I will do my best. Please, if you have any questions, just let me know, and I'll go over it as slowly as possible or as, calmly as possible. All right, so permit me to share my slides. And,
Please do.
screen. Uh, all right. Uh, can we confirm that we can't see my screen?
Yes, I can see your screen.
All right. All right. So, like my colleague said, we are talking about architecting low-code AI solutions. And basically what that means is we'll be developing models and applications using as little code as possible, right? And today we have a lot of platforms that allow us to, you know, develop applications. Compared to 10, 20 years ago, we have a lot of user interface applications that allow us to integrate and build applications. Whereas back then, you would have had to manually write the code for each application, for each script, and so on. So today, I'll be taking us through one of those platforms and how we can develop AI models using basic code, SQL, and UI features. Our agenda will be the session structure, introduction, course content, practicals, and then the key takeaways. Now, for this entire course, we're trying to be as detailed as possible. So I'll be taking us today and in the next class. And for today, this session will include, our first session will include focus on BigQuery ML and what BigQuery ML is, what foundation models are, and then how the concepts and how to architect those models so they are, well, there's a standard to developing applications. You can't just start from the end and expect it to work or from the middle. You need to start from, well, one and then build all the way to 10 or to 100, right? Following that straight line of procedures and processes. So we'll focus on BigQuery ML, and then the next class we'll talk about Auto ML, which is Google Platform's AI automation training, right? It automates the training for your model. So, like I said, originally we would have had to manually write code to train these models, to deploy them, but now we can just basically use UI, right? And interacts with their backend, and then we have our mocking models for our desired use case. And then also for each session, we'll have practical applications. So I'll show you the platforms and we'll build basic models, we'll run evaluations, predictions, and then we'll see how our model is faring, right? When we test it with new data and unknown data. So what is low code AI? Like I said, it allows us to do more than we could have done 20 years ago, right? Traditional coding would have involved writing Python code, Java, R, whatever language that you are comfortable with. You would have had to use that to develop your application. So you would go script from script, file from file, process from process, function for function. But today you have AI platforms, right, that allow us to move elements, drag and drop elements, and then we have an application working in hours. Whereas back then we would have had taking what 10, 20 people months to do it. Now you can do two, three people with a good subscription to a good AI platform. You could do a lot more in hours now, right? So why is it important today? Like I said, the speed to deployment. We are pumping out or deploying a lot of machine learning models, deep learning models a lot faster now than we could have done back then, right? And this has just aided the speed to project deliveries, business client satisfaction, just because we can do a lot more quicker. So although we still have to focus on the technicality of what we're trying to do, the rough work in the sense, AI does that for us now. So we think and we get AI to do the heavy lifting, right? And then there's reduced deployment costs. Like I said, it would have taken 10 people to build a particular model 30 years ago. Now, engineers and a platform working fast, and your deployment cost has drastically dropped, right? And then the business accessibility. So, like I said, even non-technical users, once they know how it works, can deploy their own models just because they don't have to necessarily write code as much as before. So it's making it more accessible all around. So like I said, the AI solution lifecycle, you can't start from the back and expect it to work, right? You need to follow the life cycle. That's the word. So you always start with the problem definition. So what does our business need? What are we trying to accomplish? What's the problem? Why aren't we selling goods? Why aren't we making money? Our investments aren't returning. So now once we've defined what the problem is, because it could vary in any domain. It could any business use case. Once we identify the problem, then we decide our data. So we decide on what data we're going to use to train our model, what kind of data we need, where we get the data from. It'll most likely be company historical data, right? So if it's a company, it'll be a sales company. And for our use case later on in the class, we'll be using, we'll be, we'll be developing a model, right, to make predictions for a business chain. So like a big sales company, the different stores, we're going to develop a model to predict their sales prices into the future, right? But more on that later. So once we know what data we're going to need, we'll need to collect, clean, and structure the data for our model training. Then we decide what type of model we want to use. Now, this, like I said, all these are very important steps in the life cycle and need immense intention because if one step goes wrong, you lose so much work. Even if it's easier now, you have to pay attention to every detail along the way. So we're deciding on what model we select, the different models for different use case. It could be a regression model, it could be a classification model, or a time series model, right? Regression is when you're comparing your independent values. You're comparing how your independent values affect your dependent values. Like, it could be how weather is going to affect the roads in Lagos, for example. Once it rains, you know that it's going to be traffic. So you, as a business owner, you could decide that, okay, let me save all that for later, to be honest. But we're going to decide what models we'll select for our use case. So it could be regression, classification, or a time series forecasting model, right? And then after we've decided on the model, we've trained our model, we've made predictions with our model. So we see that, okay, this does solve our problem. We can see what our prices would be like in the future. We can see that, okay, it's going to rain, and then we need to get this amount of buses on the roads or this amount of bikes on the roads because, well, this is going to happen, and we need to be prepared for that to make the most of our resources, right? So we have good return on investment and all that. So you deploy our model and then we start using them in our system. So you now just use UI to interact with the model, and then it develops or it gives you your forecasting results, your predictions. And then we monitor. And this is also a very important part because without monitoring your models, you can't evaluate to make them better because the goal is always to make it better. You can't just make one model and then leave it as it is. You need to make sure that the next predictions are always better. The loss has reduced. And like we'll talk about this more and more, but you need to always think that architect in mind is how can we make our model better? How can we reduce the loss between the predicted and the actual value, right? And so many other things. So the whole point is to track the performance, retrain the model, and optimize continuously. Always optimize. So the architecture thinking mindset. Now you have to think in systems, you have to design for scale and design for monitoring, right? When you think in systems, basically all it means is you're not thinking about uh standalone points in your model, right? You're thinking, how can I get all these different standalone points to combine into a major system, right? So we want all the different elements in our models, right? So we could have 5 models, right? Working on different aspects in the company, but we want to make sure all those models or agents are aware of what's going on in the different departments in the company. So we're not trying to isolate anybody. We're trying to create a system that works for the business, right? To make the system, to make the business grow as much as possible. So you design for scale. From day one, you have to make sure that you're designing because if you don't design with scale, if your company decides to grow or something happens, you branch out, have subsidiaries. If you had not planned for that at the start of your deployment development stage, when it comes to that moment, you now have to start going back. You have to go back to your legacy code to try and refigure or restructure. Whereas if you had thought about scaling in mind, you'd have already put little pinpoints in your model stating that, okay, or you've made space in your processing unit, your hardwares and your GPUs and all that. You're trying to make sure that if it ever comes to it, if our model needs to handle more workload, can he handle it? Are we prepared for that? Or do we need to start from scratch? So you have to build or design in scale in mind. And also you need to design for monitoring, right? You need to make sure you know your model, if your model is doing what it was designed to do. And then once you determine that, you have to now make sure that it does that consistently. There's no drop in its so today it could be giving you good predictions. You don't want next week something happens, your predictions are off. It's going to affect your shareholders, your the business as a whole. You want consistent output. So you need to monitor and make sure that your model or your system is doing what you designed it to do at all times. So AI versus automation. Now, basically, the two differences is that you could automate the workflow. In a business, you could automate the workflow. You could, let's say you have inventory request in a company, right? And it needs to go through the different departments before you can issue that item. All right. So you could easily automate that. You could develop an application that sends the invoice or the inventory request through the different departments. And then once it's approved by the HOD, for example, the issuer, the person that requested that invoice, gets an update, right? That, okay, your invoice has been requested. You can go to the inventory or the warehouse, pick up your item and go do what you want to do, right? So that's basic automating a workflow. We don't need to manually carry the paper from one office to another, looking for this person to sign this. Everything is automated, right? So that's basically automation. Now, adding AI to your automation is that if we were going to do an automation like that, if we had an AI element to it, it would learn from each process, right? It could even be that if the user is trying to identify an item, the AI could tell the user how much is left to stock, the expiring date, and then if that inventory item is issued and we know, okay, our stock has reduced, AI can prompt the manager in house that excuse me, this stock has dropped and the last batch you have is expiring next week. I think it's best that we start to plan for a restock. And then in that sense, it's tracking your inventory for you as well, right? So that's basically adding AI to your automations. You're not just automating workflows, you're creating smart automated workflows, workflows that learn with your business, workflows that help your business. And that's basically how that's the difference. So we have different business use cases, customer support bots, right? Basic chat bots for our clients' websites that interact with the client's database to know how much inventory they have, whatever, depending on whatever services they provide. You have document processing where you can upload a document and all the information is extracted from that document and saved in your database or sent to the HOD in an email format that this invoice has this. Uh, do you approve or do you reject? Something like that. Then we can also use it for predictive analysis. And like I said, for our use case, we'll be predicting the store sales into the future, right? Basically, we'll train it on the present data and then we'll see if it gets the future predictions right, right? So we'll test and then we'll train and then we'll test our model. More on that later. And then work for automation. Like for example, the inventory use case I just mentioned, we automate the entire workflow so that nobody's writing anything manually. You just upload the document, everybody stamps on it in a different departments, and it is approved via, automated signatures. All right, so although AI has come to really assist us in our day-to-day activities, it, and I'll say this, although it has made life easier, developing models using user interface and not having to manually write code. As a person, I think it's best that whatever service or AI platform you decide to work with, you need to understand a language and understand that language very well. Personally, I use Python a lot, and I'm still learning because it doesn't ever end really. So you need to constantly be aware of your language and know how to use it if because the risk would be if you over rely on the UI features, you never really understand what happens in the back end. And if you never really understand how the back end works, then you're not really able to fully utilize the UI elements, right? You need to understand all those elements so that when you're interacting with the UI, it feels seamless. So like the risk involved and limitations are you over rely on the drag and drop features, you don't understand the mechanics, your data quality issues because you don't understand how to really maintain data or clean the data. Like I said, you don't understand how the backend works. You're not really providing your model with the best quality data it needs to train, right? And if you don't do that, you're not training the model correctly. You're leaving space for wrong predictions, hallucinations, and so on. And then it could have scalability challenges. Now, if you plant the science to grow, and you need to train. So AI, the platform we use today has a lot of automated features where we don't have to write code, yes. But sometimes it will come where you need to generate custom models. You need to train your models based on your parameters. Like, so if you're not aware of how to do that, then it becomes a problem for you when it's time to scale. And then sometimes you have integration complexities because what we're trying to do is we're integrating different systems to different systems, and some systems might be outdated, some systems might not allow a certain integration type. They don't allow webhooks or you can't make API calls to the platforms. So because of that, you might have integration complexity. And if you don't, again, understand how the backend logic works, you won't be able to come up with a solution that works for that use case. So we need to also really pay attention to that. So what are foundation models? Foundation models, now basically, I'll start with this. I hope we're all aware of the big tech companies today, Google, Meta, Tesla, Elon Musk, right? And those big Anthropic, for example, OpenAI, and all those big AI model providers now, those companies have made it easy for us to have access to their models. And their models now, models owned by big companies like that, are what we call foundation models, right? Now, foundation models, for example, why they are called foundation models is because they are trained on multimodal data, and multimodal meaning they are trained on the different forms of data. They're trained on text, they're trained to write code, they're trained to generate pictures, they're trained to classify pictures, they're trained to make translations. They're trained on so much data that if you all go to ChatGPT and ask it to speak Yoruba for you, it will speak Yoruba as basic as it is. And that's how much data it takes for a model. That's how much training is needed for a model to know all that. So my point is that when those big companies have developed the foundation models for us, so that everyday users like us don't have to do it. Why? Because it is extremely expensive to develop, train, and manage a foundation model, right? That's why you have massive data centers and you have massive hardwares, massive GPUs or TPUs, and those are the hardware processing units that we use to train our models and data. A company that isn't suited in that domain will not have the resources to handle that type of workload. So basically, foundation models are our major models that are defined on or trained on multimodal data, right? They're trained on so much data, and they are benefit, right? So the benefits is that we users don't have to train models. They already provided it to us, and we have access to those models. And again, for our use case today, the Google Cloud Console platform, we will see how we can access a foundation model, we can use it, and then make requests or make queries. So below are there are two examples. We have large language models, models that are trained for natural language processing and understanding. And then you also have vision models, which are trained for image classification and analysis tasks. This is what our cameras today use. They have vision models in the background so they can identify whose car, take pictures of your car. This is basically the use case for AI models, right? And the difference between large language, a language model and a vision model is the type of data they're trained with. A language model will be trained with a lot of language, a lot of English text generation, code writing, right? While the vision model, we train a lot of images, so we can identify different things, identify different people, and etc. So that's a brief intro to foundation model. Now we'll talk about BigQuery ML. Now, like I said, today we'll be using Google Cloud's platform to experiment and to develop a model. We'll evaluate that model and we'll train, test, evaluate, and make predictions. We'll even deploy it to an endpoint, and then we'll see if that model is making good predictions or not. Now, what BigQuery ML does, it allows us to use basic SQL code, that is structured query language, right? It allows us to use SQL code to generate a model, right? And I said at the start that naturally, even today, if you want to generate a complex model, sometimes you need to write the code, right? You need to put in your parameters, define your hidden layers, define your optimizers, your loss function. If you want something with detail, you have to do it like yourself. But BigQuery allows us to use UI elements to train our model, test it, evaluate it, and make predictions. So we see if our model is working right or not with as low code, as minimum code as possible, right? It allows for easy integration. The platform is vast that you can upload your data for testing and training. You don't have to host your database on another service provider and then have to integrate to that. Every model in the Google Cloud platform, right, is integrated. So you can easily connect one service like BigQuery ML to another service like Vortex AI, which is what we'll be working with today. Now, it also allows for collaborations between all the engineers in your company. So if we're all working on one model, we can easily make predictions, iterate. I can decide, okay, I think it's better we design our data in this way so that we can get better results, and that's what you call feature engineering, is where you try to take your original data, you extract it, you transform it into better models, better variables so that your model can easily process and learn from it, and then you test it. All right, so it allows for easy collaboration within the company and integration into our existing systems as well. All right, so the learning objectives for BigQuery will be this is a so BigQuery would have a workflow, right? And the workflow for BigQuery is you always start with your data source. You always need to determine what data sources you would use to train your model, right? And the BigQuery is BigQuery machine learning, right? So that's what BigQuery ML is. And so you need to start at your data source. You need to identify what type of data, where you getting your data from, uh, and what type of data you'll be needing for your use case and so on. And then you move on to feature engineering. And feature engineering basically is if you have a data set, a basic CSV file, an Excel CSV file that has the company's sales data, right? And you have a couple of columns and a couple of rows, or 1,000 rows. So it could be 10 columns and 10,000 rows based on the company's data, or yeah, right? And but you know that all this is a lot of information. Now, a lot of data analysts, data engineering, and data scientists, they focus a lot on the feature engineering, because when you have the best columns available, you could generate the columns from combining two different columns. So you could either have, let's say, the sales the store ID and the product ID. And that's what we call a time series identifier, right? If you wanted to, you could combine those two columns together to get a new column, and we could call that the time series identifier. Now, what that does is it has helped our model, it has made it easier for a model to make its analysis and to learn from that data set. So now we don't necessarily have to use those two individual columns. You can just use that single one, and a model knows what we're talking about. And that's just a basic level of feature engineering. You could have feature engineering where you're combining two different columns with formulas in between to get a particular endpoint. So it could be uh, column one to multiply divided by 0.5 times columns two divided by multiplied by, and so on and so forth, just so you can get the third column, which is what we know we need for our model to really understand our data better. So that's what feature engineering is. So then and again, we'll decide on our model, right? So we decide what type of model we'll be training. And like I said, the different models for different use cases. And before our use case, we're using a forecasting time series model, linear regression forecasting time series model, right? And then we'll move on to the next step. We have model training. So after we've decided on our model, we'll train our model, right? After we've prepared our data, we feed it into our model, and then we monitor and see how the training process goes. You can determine how many times you want your model to train. It could be one, two, three. But like I said, BigQuery does a lot of the dirty work for us so that we don't even need to focus on that. All we just see is the results. Once we see the results, we either decide, do we like it? Do we not? Do we need to go back? Do we change our data source? And so on. And then that's where we move to the model evaluation. After we training, we see does our model, is it working right? Is it not? And so on. And then model predictions. This is after we have evaluated our model, and then we as the engineers deem it worthy to be deployed, right? So we think we can start making predictions. So predictions usually involve so you have training data and you have testing data. They're usually from the same data source. It's just that you take a portion of your data set, like 80%, and then you call it your training data. The other 20% is your testing data. So that's like you train your model with data from uh, 2010 to 2019, and then you test your model's prediction with data from 2020 till 2020, or yeah, 2020, right? And then you see if it gets the actual values you had in 2020, if it predicted them right in a sense, right? So I'll show more once we start to look at it visually, you understand more what I'm talking about. Now, again, the workflow, data processing, feature engineering, model training, evaluations, and predictions. Predictions are the end results. Are we getting the value for what we offered, and so on and so forth. Now, the start of every workflow is your data source. Where are we getting our data from? And for this class, you could get it from Google Data Search or Kaggle. And for this class, we'll be using Kaggle data source. And then I'll walk you through developing or downloading a data set for our use case, cleaning up our data sets. We clean it up, we extract, we transform it, and then we load it into our system before we before we do more feature engineering, and then we train our model with it. Feature engineering, the next step. So this is when you select the relevant variables. So like I said, you could have 10 columns, but you only really need 3 or 4. So you could feature engineer the most of them and then clean up the rest. Because if you're feeding your model with unimportant or irrelevant data, it just brings out wrong prediction. It's not allowing you to make the best of your hardware because they are training it with unnecessary information. So you handle the data, you make sure it's clean, you make sure there's no missing values or any errors that could disturb your training process. And then you convert them into your new features, your new columns, making your model learn accurately. And then we choose the right model. So like I said, we have different types of model. We have classification, regression, and the time series, right? So the classification models are just used to they're used to determine or classify two different types of objects. For example, you could have pictures, you could have fraud, you could have churn rates, or you could have pictures between a cat and a dog, and your model basically just this kind of model basically just going to separate them into their different classes. A class for dogs, a class for cats, a class for fraud, a class for non-fraud, uh, a class for clients that will most likely leave our services, and a class for clients that we know based on our predictions won't leave, right? So that's basically what it is. We'll train our model and then it'll be able to tell us what is what belongs to what class. Now, regression, on the other hand, is when you're trying to understand how a particular variable affects another variable, right? So you want to see if there's a positive reaction to your increase to the weather and your increase in sales, or to the car engine type and the increase in sales, or the core car color and the increase in sales. You can even do multiple variables. You could be car engine, car color, is it four-wheel drive? Is it the Jeep? Is it a Hummer, what, depending different, different attributes of your car. And you could take all those different attributes and see if they affect the price. So it could be this kind of engine. Are we getting a lot of sales on it? This color, is it affecting sales and so on? But usually they start with a single regression. So you just use one variable and you see how the independent variable affects your dependent variable. And then you have your time series models, which are basically models that are forecasting to the future. So you train them on your data today and from historical data, and you tell it to predict what our sales will be like in 2027, right? So that's basically what it is. It can see what's going to happen in the future, provided you provide it with all the needed information and parameters that affect our company sales. So the right data, basically. So data is very important. If you don't train your model with the right data, it will make the best possible predictions for you. So we'll briefly look at the model evaluation metrics, and my colleagues later on in the class will really cover all these in details, right? So we'll talk about precision, how precise was your model of all the items that were predicted, how many were correct. And then you look at your recall that, so if we have a data set of 200 values and your model returns 100 as correct values, out of the 200, out of the 100, how many, so out of the 200, the total data set, are there really only 100 true values, or is there more, or is it less? Right. And then we talk about the ROC curve, look on that later on. And the curve just tells us how well the classification model separates its classes. So it's going to plot the true positive rate versus the false positive rate. So it's basically just the true positive versus the false positive. And then you see the line of graph and you see that is it getting it right or wrong. And this further model evaluation metrics, a confusion matrix. And then this table compares the actual values versus the predicted values in the classification model. Uh, you should see the graph along the course. And then you also see the precision recall curve, which shows us the trade-off between our precision and our recall, because there are two values that we monitor, the precision and recall. So are we growing? Is it getting better, or is our curve dropping? And then we also look at the loss, right? There's a loss graph. The loss graph also measures the difference between the error between the predicted value and the actual value during training. But basically, a lower loss value equals better model performance. So then after we evaluate our models, we'll generate predictions. So we'll use SQL queries to generate a prediction. We'll see our forecasting model, if it performs well, is it getting, so basically what happens is after we test our model with predictions, if it's getting good enough values, we can say, okay, let's deploy this into our systems and have it making actual predictions for the company and so on. And then we can, like I said, so then after we're sure that it's making good predictions, we can integrate it into the company for the business use cases, whatever it is, we're now making good. So like the business analyst can now make predictions and then see, okay, do we need to do how we need to approach our problems and to make things better. Now, the other service I said we'll be looking at on the Google Cloud platform is the Vortex AI. Now, this is Google Cloud's AI service where you can do the entire machine learning lifecycle using AI and UI elements. So, like I said, we barely use any code throughout this course, but it's still best that you understand whatever language that you are working with. So what is the importance of Octex AI? It's a unified machine learning platform that allows us to streamline the entire machine learning lifecycle. So right from the data source, where we interact with our data, then we do feature engineering, we select the model we want, we train the model, we evaluate the model, and we make predictions. We can do all that using Vortex AI's software and the different elements that make up that service. So the key capabilities include, the key capabilities include data processing and exploration, feature engineering, automated model deployment, model training options, model evaluation tools, and continuous monitoring and automation. Now, it allows us to process our data. We can ingest our data, prepare the data set, clean it, select the features that we want to use, and then we use UI-based data workflows to handle the processing from where we stored our data and to where we'll train our model. And that's basically the integrated tools for preparation. So it automates our model deployment, right? So it streamlines the entire machine learning and auto ML workflows, right? Basically, what auto ML is Vertex AI machine learning service. So instead of us writing the code to optimize it, to calculate our loss function, and to determine the amount of iterations, AutoML does that for us. We just need to click on the service or the element, and when we're creating our model, well, we'll see that in the next session next week, but it's good that you just understand what that is right now. So we look at feature engineering processes are simplified. We can select our model without having to write code. You actually just use your mouse and click on the model you want to use. You can fine tune your hyperparameters, and that's basically briefly, hyperparameters are, well, the parameters that we track to see how we can make our model better. So if we use a particular hyperparameter today, and then we train our model, right? AutoML tracks the parameters we used and then fine-tunes those parameters so that when we run the training or prediction again, we should get better results. So hyperparameters basically are just those parameters that we use or we track when we're training our model. So it allows us to fine tune them efficiently. And because of the AI platform, we don't have to write as much code as we would have had to. Most of it is already automated. So the training is optimized and then production ready models in record time. Because we're not writing as much code, but shipping out good models, but it has to be efficient. But we're shipping out models as productively as possible. Then we also evaluate our models, make sure that our models know, make sure our models are performing to the standard that we designed them to do. We'll track the metrics. And those are the metrics that I discussed earlier, the precision, recall, ROC, the loss function, and so on. So we track those metrics and we see how our model is performing. Now, this is the end-to-end machine learning pipeline, and this is what Vortex AI platform provides. It allows us for data processing, data exploration, model training, and then model deployment, right? So the entire work, the entire life cycle pipeline can be done using Vortex AI. Traditionally, you'd have had to use different elements, probably store your data on Google Drive, and then write your code in Google Colab or and so on and so forth, right? Even to save your model, deploy your model, you had to, after you're done training your model, you had to look for another service provider that will help you deploy your model, and so on and so forth, right? But what Google Cloud Platform and the Vortex AI service has done is they've given us all that into one service. So we just stay on one software and we're doing the entire thing. So we'll also look at model guarding. So what model guarding is Vortex AI guarding for models, like the name implies. So it's just it, if you say a garden, it has a bunch of flowers in it, right? So what model guarding for Vortex AI is a garden or a page or a service that has access to all the foundation models that we discussed earlier, right? So you have models that are provided by OpenAI, models that are provided by Elon Musk, Tesla, or models are provided by Meta, right? Facebook, all those models by the different Anthropic, all those different models, you can have access to them on Google Cloud's model guarding. So you can use your model, your foundation models, you can do RAG architecture with it, and we'll talk about that, right? And then you can fine tune those models to serve you as diligently as possible. So it allows for easy integration with those models, and then you can integrate those models with your applications, right? So instead of having to train a model, you can just sign up for that platform, deploy a model, get the model credentials and plug it into your application, either locally or your system, your company systems. We'll see more of that. We'll see more of that later. So now we'll talk about retrieval. And before I get into this, are we all good? Is there any questions so far? Am I making sense? Can we hear me?
We can hear you.
Yes, we
No,
can hear you.
All right. Are we following? Am I making sense? Is there any problems?
yeah, you're making sense, but personally, I believe once we enter the practical phase, I think things will be more clear as this is
All
the
right.
start. Yeah, thank you, sir.
All right. All right. All right. No problem. Oh, thank you. So, like I said, if anything, I'm happy to slow down and reiterate. All right. So I'll
Thank you,
keep
sir.
going. No problem. I'm
Okay.
glad we're following.
I just have a question, or maybe later.
No, you can go ahead.
Okay, thank you so much for the lecture. Uh, I, I was just thinking in my mind that are we able to generate a new AI architecture with this, following since we started? So I was just thinking, that is it possible to generate? Because when you are saying model, I was thinking, is it like we are trying to develop a new architecture, maybe to solve a particular problem, especially in the time series model that you mentioned? That is it possible to maybe that is tailored for a particular problem? Thank you, sir.
So, well, yes, when we get to the practical, I will walk us through developing a model. And when I say model, I hope we're familiar with ChatGPT and how we use AI today for basic tasks, basic prompts. Now, behind that user interface that we all know and use is an AI model working to answer our questions. So like I said, behind that user interface is a foundation model, right? Trained on so much data that it knows a lot of things, right? So what we'll be doing today is instead of developing a model for text generation, that's what we call it, or code generation, but developing our time series model to forecast prices. So this model is designed just to make predictions on our sales, right? So the use case for us today is we're trying to see if we can predict how our sales will look like in 2027 today. So I hope that answers your question.
Thank you, sir. It does.
All right, no
All
problem.
right, sir. Thank you for the training so far. I really appreciate your commitment, sir. So my question is that based on what you discussed so far, so I could assimilate that it's like we are building up a machine learning model. If I could understand what you have been saying, sir.
Yes, that's exactly it. We're building our own machine learning model.
All right, sir. So it means by the end of this session, we are going to bring up something pertaining to the example you've given, like ChatGPT, OpenAI, and the likes.
Well, yes, but it will not be as massive as the ChatGPT ones. So because we're
All right.
training it on one type of data. Yeah.
All right. Yes. Based on what you said so far, you said something about the data. So me personally, I am a beginner. So how do we go about that? Or by the end of the session, you are going to walk us through. Thank you, sir.
Yeah, you definitely see how you get your data. But like I said, if it's for your company, it's better to use your company's data. But because this is a course and it's best to use practical free data, right? And they have different data sources online. So I'll show you a data source where you can get data from, and I will download that data and then we'll upload it into our Google Cloud platform, and then we'll see how to make a model and interact with that model.
All right, sir. All right, sir. So, with this, I think we could work for people like, maybe perhaps the structure is not for our own personal business, so we can use this training this learning model, this machine learning model for other businesses aside from ours.
Yes, it always determines. So like I said, you always start with your problem definition. You determine what is the problem, what domain. It could be in finance, it could be in tech, it could be football company trying to see who the next best player is or who will win the EPL. It could be for different things. But the main point is whatever problem you have to make sure you're getting the right data, the right model, and you're training it right.
All right, sir. Thank you, sir. I really appreciate.
No problem. All right. So if there's no more, I will just continue. I wanted to make sure we're following before we got into this next part. Now, we'll talk about RAG, and what RAG is: retrieval augmented generation. And in basic terms, if you had a model that you have trained for something, right? It could even be the foundation model, right? But as we said, foundation models are they're multimodal, so they know a lot about everything, but it could also mean they know a little about certain things, right? So if we wanted to get a foundation model to work for my company. And I just wanted to be like, okay, I just wanted to reply my chatbot feature on my website. But I'm sure the model, if I ask the model directly, do you know my company? It will tell me something generic because it's a very big world. So, and there's so many companies, so many things on the internet. So it might give you the wrong answer because it just doesn't know or hasn't been trained on that data. So what RAG does is instead of having to train, it's another way to fine tune your model, basically. So instead of having to create a model from scratch, right, to serve your use case, which like I said, is very resource demanding. You could take a foundation model, right, using code and UI elements, and you combine that foundation model with your information. So like company documents, right? You could train that model on your company documents. No, sorry. You could combine them. So there's an entire process to 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 RAG, right? But I'm trying to start off slowly. So basically, once you add your company documents to your model now knows about your company. So if you were to now ask your client, your model about my company, it would give you answers directly from that document and not answers it got from the internet, right? So that's the basic idea of RAG. It's called retrieval. So you retrieve, you augment, and then you generate a response. Sorry, hold on. All right. So you retrieve, you augment, and then you generate the raw. So your model will retrieve the information, will augment it. So based on what your query was. So if your query was, what does my company do? Or for example, my company was PSC do, it would go to the documentation, find out what I define my company as, it will retrieve it based on semantic. All right. It will retrieve that information and then it will show the user as a question. Now, the technical aspect of RAG is we have terms like vector search, which basically just means that the model performs a vector search into your database, which is where you store your company documents, and based on the embeddings. Now, embeddings basically are when you convert your text into the corresponding numbers. And I won't focus too much on that, but I think you should know what that is. So next time when you come across RAG, you're familiar with what's happening. So you have to convert your text to embeddings. Now, the embeddings is what our model used to perform vector search. And then when it performs a vector search, it looks for the model. So it will convert, let's say, let me start like this. Let's say the user comes up or I come up and I say, what does PSC do? Right? For the RAG architecture to work, it's going to convert that sentence into embeddings, right? So embeddings are basically just the number correspondence of your sentence. So you're converting your sentence into words, into numbers. So 1, 2, 3, 0, 0, 9 binaries so your model can understand, right? So once you convert that sentence into embeddings, you would have already converted your documents into embeddings as well, right? And there are basic features, there are basic tools that can help us convert text to embeddings, right? So once your model converts your text to embeddings, it goes to your database, looks for the embeddings that are similar, the embeddings numbers that are similar to the ones that were in your sentence. Once it sees that similarity, that's what you mean semantic feature or something, right? Once it sees that similarity in the embeddings, it retrieves that embeddings from your document, and then it converts it back into text, and then it shows you your information that you desire, right? And I'll show you this in our platform once we get into the practicals now. So basically, that's what RAG is. It allows you to uh, augment your information with a model so you don't have to train your model because we could have trained the model, but if you don't have the resources for that, you can use RAG. All right, so now we'll move into the practical aspect of the class. And like I said, our session one practical will focus on BigQuery ML. where we'll build a model using SQL code, we'll train the model, we'll evaluate the model, and we'll make basic predictions and we'll see how our model performs, right? We'll also now look at Vertex AI's model garden, which is where they have all those foundation models we've defined, and then we'll deploy one, and then we'll make iterations. We'll try and get that model to answer our prompts, no matter what the prompts may be. And then we'll also now show you what RAG looks like. And I explained the backend a lot, but when you see the UI elements, you see how easy it looks, right? So we'll also look at RAG in the practical. Now I'm going to stop sharing my screen and then we'll move into the practical aspect. All right, so here we are. I'd like to confirm, can we all see my screen? All right, thank you. Thank you, sir. So like we said, we'll be looking at Google Cloud's platform console. And this is where we'll be doing a lot of the practical throughout this course for the most part. And I will try to introduce it as best as possible. So naturally, you go to Google and you just Google Google Console, and then you click on the Google Cloud Platform, right? This is where you naturally sign in, create your profile, and then we get for every signing you get $300 free working credit. So this allows us to experiment on their platform without having to pay the bills that come with it, right? So this is just free credit we can use. So once you sign in and you create your credentials, you click on the console, just right at the top of the screen, right? And then here we are. This is the Google Cloud console. All right. Now, naturally, the next step would be to create a project, right? Because that's what we'll be working with. So you click here and then you click new project, right? I won't be doing, I'll just say this ahead. I won't be doing I'll be showing you how everything is done, but we won't naturally run a lot of the building processes because those ones take time. So what I've done is I have prepared a lot of the solutions ahead, but I'll show you and walk you through how we got to each solution. All right. So like I said, this is a new project, and then you put whatever name you want here, your organization, if needed, and then you create. Once you create your project, it pops up here. So now you see I have the AI automation specialist project I've created here. So this is my project, and this is my project ID. All right, so I'll click into my project and then this pops up. So now we're working within my project. And as you can see, ah, that's funny. As you can see, I have some credit, so that's what I'll be working with today. So first of all, we'll start with Google BigQuery ML. And if you look here, we can see the different services they provide. You can create a virtual environment, but we won't do that today. We'll train and host a machine learning model. So we'll do Vertex AI today, but that will come after BigQuery. We'll create our database on BigQuery using basic SQL code, and then we'll use BigQuery. You could also embed your map platforms, create Kubernetes clusters. You can deploy an application, create a storage bucket, which is just a database or knowledge database that you can store your information. You can even convert text to speech using API, convert speech to text using API. Now, this is all the products they provide and many more, because if I click on here, there's so many services that Google provides, but we won't be looking into all of them today. We'll just focus on BigQuery and AutoML and Vertex AI. All right, so like I said, we'll start with BigQuery. So before we start, I want us to we'll walk through the machine learning workflow, right, with BigQuery. And first of all, we have to determine what our business use case is. And like I said, for us is we're trying to forecast the sales for our company in the future, right? So we want to use our present day data to forecast if our sales in the future will either rise or fall based on different variables. Like if store one and store two, will their sales drop in 2027 or will they increase based on historical data, right? So that helps the company prepare ahead. So do we need to now buy more of this particular products, or do we need to hold on these products? Do we need to do promotions? How do we sell more products? It just helps in the entire business plan, right? That's what making prediction does. So like I said, we'll start with getting our data first, the data we'll use to train our model. And what we'll do is we'll go to Cargo, right? Naturally, you could just search it. Right. So if you just went to Cargo, just Google basic Cargo will come up. So this is your machine learning and data science community. It's a community that has so much data for different use cases. It's almost endless, right? So we open Cargo. Naturally, you have to sign in, create an account, so before you can get access to their data sets. So if you look on the left, you can see all the data sets they have, but we'll focus on data sets today, right? And this is the data set we'll be using today. It's a time series practical data set. And if you look over here, we can see that we have test and our training data set. So this is the test will most likely be data from uh, 2009 till last year, or from 2009 till 2024. And our train data, sorry, will be from 2009 till 2024. And our test data will be from 2025 till date. So we're just splitting our entire data set into two parts, 80% for training, 20% for testing, right? So note that because that's very important when you in doing machine learning. So we will download both files, and naturally you just do this and you download the zip file. And once you have that, you should have that in your downloads. So this is it. All right. But what I'm going to do now is, and what I've already done is I've cleaned the data so that it makes it easier to upload into our Google platform. So, and also because of training purposes, I don't want us to use data sets that are too massive, because if we do that, then it just takes too long and it eats too much of our resources, right? So I've tried to make sure our data is lean and as clean as possible before even uploading it. And I can show you what it looks like in my Excel here. So this is what it looks like, basic. So this is basically our BigQuery data, right? It was a lot more, there were a lot more columns than this, right? A lot more rows, but I've tried to clean it up to make sure we only have what we need. So what we're going to do now is we're going to upload our BigQuery data into the Google Cloud platform, and then we'll start to feature engineer, and then we'll train our model. So now that we've determined where we're getting our data source from, let's go back to our platform and then upload that data. So as you can see on our left, we have our project. And our project hosts different files. So it has our repos, our queries, our notebooks. And if you're familiar with notebooks, we have Google Colab, and this is just a platform that allows you to write code without having to worry about the hardware for your processing. So like I said, you'd have used Google Colab to train your model before you had to move it to a platform like Azure to host your model. But now you can do all of that on BigQuery ML. So I'll show you what notebooks look like. I'll show you what queries look like. And we see our data preparation, data canvases, our pipelines. A colleague of mine will talk about this in the future, our connections and our data sets. So what we're doing today is going to create a data set for this project. So we'll click on the three dots and we'll create the data set. We can name it what we want. For this class, I called it AI Automation Specialist Data Set. I will determine our location. Now I should say this. Your location basically refers to where your data center is, right? Your data center is being hosted. Naturally, it's best to pick a location closer to you, your company, or where your client base is, right? So reduces latency in a sense. So if there's any need for API calls to the database or to a data center, it's slower because it's already within our region. Now, we have a lot of locations, but the ones that we're using today are the US Central Loha and Loa and the Europe West Netherlands. Now, why? Because these two locations have what I'm looking for. The Europe one is closer to us in Nigeria, so that's why I'm choosing that. And it also has the SDKs and libraries that I need to work with, so I don't have to reinstall certain things. It already comes installed in that location, right? And certain features are enabled in one location are not enabled in another location. And another thing to track your data location is important because if you create a model in one data location and you want to use it in another data location, it won't work because you need to create your model in the same data location as what you want to, your same endpoint, for example. You can't basically just pay attention to your data locations. They are very important because if you don't, you lose your models. Because if you don't pay attention to where you're deploying a model, it could go up in Southeast Asia. And if you don't know, you end up deploying the same model over and over and over again because you don't know where your model is at or your data set is at or whatever training or so just pay attention to your data locations. So like I said, for this one, we'd pick uh Netherlands because it's closest to us. That's the reason why I picked it. It's closest to us and it has the libraries that I need to work with. So I'll pick this and then I'll create my data set. Now I'm not going to do that because I already have, but that's the procedure to do that. So once you click that, it pops up here. Now we have our data set. So this is just a data set that hosts the different tables that we're using to work today. Now, when you say data sets, you mean all your data sets. And then when you talk about tables is each individual data. So each individual CSV file or text file coming together to make your data set, right? So in our data set now we have currently one table and I'll show you how to create a table. So once we open our data set, right, we could either do this. Sorry, hold on. We could either do this, create a table, which brings out this pop-up box, or we could click create a table in our data set. So as you can see, we're working now in our data set. Let me show you this again. So as you can see, this is our project here. This is our data set. And then this is our data set folder. Now that we're working on our data set folder, let's create a table. Right. So like I said, I'll just show you how it's done. we need to determine where we're getting our data, our table from. Now, when you say table, now we're talking about the individual files that we want to upload. So is it the CSV file or the text file or the images, all that? Where are we getting it from? So we could either get it from Google Cloud Storage, upload, or we can drive from Google Drive, Google Big Table, Amazon S3, Azure and Bob Storage, all those different ones that data providing. Sorry, hold on. All right. So I was saying we have to, well, determine where we're getting our data from. And for us, for this class, we'll upload it from our local laptop. And then then we now select our file. So now we're going to get the data file that we had earlier cleaned locally using Excel, right? So we want to upload that file. So here's our file, the BigQuery data. Now all I need to do is click on this, open it, data pops up, the file type pops up, the destination, our project, our data set, and then we name our table, and then we just name it AI AS table, right? And then we need to click auto detect so it determines that our table has headings. If not, it might have a problem while uploading. So we click auto detect so that it knows that our table has headings already, right? So we click auto detect and then you click create table. So once you click create table, naturally the table pops up here. Now we'll go into our table to work. So now we look at the table and all the features. Before that, I should actually work you through this. So you see, back in our data sets, I need to show you, I think it's best to show you the other pages. So you can see the overview of the tables in our data sets. You can see the details of our data sets, data set ID, when it was created, if it has an expiration, the last date modified, our data location, which like I said is important, and travel time, other credentials, right? And then also in the data set, we can look at the models that we've created in our data sets, but we'll do that after we create a model. Right now, let's go back into our table and we'll do some work there. So now that we're in our table, you can see let's interact with the UI, right? So we can see the schema. There's the data, the store, the product, and the number sold. So this is basically what the information is. I should have defined this. So this is the date in which that item was sold. This is the store in which the item was sold from. So I think we have store numbers from 1 to 6, and then we have different products from 1 to 8, and then they have the number of products sold. So it goes up to about 900 products sold in that particular day. So this is just understanding the schema. And like I said, I cleaned it up so that only the relevant columns are kept. So we look at the details about our table ID, when it was created, the location, and then storage info was a light table, so that's fine. We look at the preview of the table. So we have the rows, the dates, the store, the product, number of items. So you can see we have about 839 items stored on one day, right? And so on and all the way. So a thousand here, 1,057 here. You can also explore the table some more using SQL code, but we'll look at that. You can see the lineage. So basically, you're seeing where the table came from. So it came from, one sec, it came from our database, but because we have not really developed a lot of tables or workflows around it, you can't see much. But you see this table, and we'll create this table view in a second. So you can look at the lineage, and basically lineage just shows you who the parent to the table is. So if you make a subsidiary under this table, like a view, it shows you where that view was coming from and where that table was coming from. So the table comes from our data set, yeah? And then you can also look at the data quality. Well, all these we need to, but we won't be doing any of that today. We'll just create a model, and I just wanted you to see it. So back to our schema, right? Now that we understand what's in our table, let's query our table and let's, create a model, right? And we work through the workflow. So again, I've prepared all the queries that we'll be needing. And if you're not familiar with SQL, I will advise that you please look it up and learn some things about it. It's easy to learn, it's straightforward, and thanks to BigQuery, you can create a model with basic SQL code. So I'll show you the queries. And then first we're going to query our model to see what's in our model, yeah? So basically what this code is, let me see if I can zoom in a bit now. Yeah, I assume this is better. Yeah, I assume this is better. So uh so first of all, we'll start by querying our model, right? Our database to see what's in our data. Naturally, we just do this to see what columns are available and see what we're looking at. And right now in our workflow, in our pipeline, in our workflow and our pipeline, we're still at our data preparation stage. We're still trying to do some feature engineering and see how to get the data ready for training. So what we do next is we're going to see what's in our table. So this is a basic SQL query, right? It's a basic SQL query. And what this says is select asterisk, meaning select all from our table. So this is our project, our data set, and then our table, right? Which is this table right here, which is this AI automation table right here. So if we run this query, naturally we should see what's in our table, and I'll run it. So as you can see, this is basically what's in our table, our dates, store, product, number sold, right? So let's move on. So this, like I said, is a basic SQL query. All right, and for this, so now we're looking at cleaning our model. We're still in our data preparation. We haven't started feature engineering yet. We're just building up steam to get there. So now that we're trying to see if there's any missing values in our data. And like I said, if there's any missing values or null values that could really affect our training process. So let's run this SQL. So this is just saying select from our table, right? And count the date. Right, so that's our dates column that we see here. So count this dates column, right, and check if any of it is null. And if any of it is null, return it as a column called missing dates, right? And then you should also not count if our column number sold is null. So if we have any rows that is null, and if we have any no rows that is null, create a new column and call it missing target, right? And then we say select these variables or these columns, and we'll define it as this from our data table. So this is our project, our data set, and our table. Now, if I run this, we should see if we have any missing values or not in our data set. And lucky us, we have no missing dates, no missing targets. And our targets is basically our number sold. That's what we're trying to predict, right? That we're trying to see if our number sold will increase in the future or will drop, right? So that's basically it. So now we see that there's no missing dates or missing targets. So I think that's good for us to move on to our feature engineering, right? And then see how best we can prep our data to fit into our model. All right. Let's see this. All right. So we're going to our next query, which is basically we'll do some, so yeah, so the next thing for us to do is now that we have our table, we're going to create a test view. This is when we create we create a future engineered look of our table, right? So we're going to modify some code and see how best to feed it to our model. Okay, so here we go. Now, to create a view basically is feature engineering, right? So we're going to a view it's a different view of our original table, like the name implies. Right, so you use the SQL code create view, right? And then we'll tell it where we want to create this view. So we want to create it in our data set, our project, our AI data set, and create this table view, right? So, and then what do we want to include in our table? So we select our date, our store column, our product column, our number sold column, and then we now also create a new column for our time series identifier. Now, this column basically just helps our forecast model track what's going on better, right? So we concatenate, and that's what this command is. We concatenate, which basically means you're combining two different columns to one, right? So we concatenate our store column and our product column, and then we call it our time series identifier. It's a column that is needed for any time series forecasting. So it's an input column that is needed, right? And then we also partition the row numbers by date, and then we order it by the number sold. So this is just basically so we can arrange our table the way we want to arrange it, right? So we arrange it by the number sold in descending order, and we call it our product rank in store daily. So basically, what product is hosting the highest amount of sales daily, right? So what product are we selling the most? And then we say from our product. So where are we going to? We're going to create this new table. We're going to select all these variables. Even do this part here is the feature engineering part. So this is basic feature engineering, but that's what is happening here. We're maneuvering or manipulating our data to create new columns so our model can learn easier, right? So after we determine what variables we need, we select it from we're telling it to get this information from our original table, our initial table. Then we should order the table by the date, store, and then the product ranked and stored daily. So basically, we're just saying this is how we want to order our table. So if we run this SQL query as it is, we should have our new model, our new view created right here. So basically, all you need to do is just run. But as you can see, it's saying already exists this table view. So I'll just go there and I'll open it and show you what it looks like. All right. So now we have our table view. Now, basically what this is, so we have our table view. And basically, like I said, it's just a different look is a feature engineered look of our original data set. And as you can see, it has more schema than the original one. So we have the dates, the store, product, number sold, time series identifier, and the product rank in store daily. So I see some questions in the chat room. Because I'm trying to manage my time, I can essentially walk you through each step, but I believe the class is recorded, so you can naturally just go through it and follow the steps step by step to get to your solution. And yes, it is free. You have 300 free credits once you sign up for about 90 days, so you can use that to maneuver when needed. So I hope we're all following, but like I said, so this is our schema for our view, right? And you can see it has more columns than the original table because we feature engineered these two columns so that our model can easily learn from it. So now six we have six tables, six columns in our table view. We can look at the details. inside lineage. And if you look at lineage now, you see that it comes from the original automation specialist table, right? So that's how we know that this is lineage. It shows us our lineage, right? All right. So now that we have a different table view of our model, of our data set, and we have featured engineered, it's time to select our model and create our model. All right. So we'll move on. And like I said, we'll be using SQL code to do this. And to create our model, we'll do this SQL. All right, I can also share all these SQL queries, so I can download them and share them to you so you can easily access and run your own code in your own time. So I intend to provide all these to make it easier for you to learn. So now we're going to create a model. Initially, we created a view. Now we're going to create the model. This is now when we already know we're building a model for forecasting, right? So we'll now select our model type. All right. So again, we'll create our model. AI from our project. So well, in this script, we're going to say where we want to place our model. So we want our model to be placed in our data set models, right? And then we also select an option, which is basically the model type and the input label column, right? So what column are we tracking? What column are we trying to predict? Our number sold, and what is our model type? Linear regression, because that's the type of the model we're using. So after we determine this early variables, then we now select the information from our table, right? So what we're doing is we're training our model with our view, not the original data set, because we already feature engineered our view, right? So we're going to train our model with our table view and not the original data set. So now that we've defined our model, we've defined the options, the model type, linear regression, and then the input label column, which is our number sold, we now select our tables, the information from our table view, right? So our date, our store, our product. So this is all the information we're training our model with, basically. And we're telling it where we're selecting it from. We're selecting it from our AS table view, right? Not the original table. So as you can see, we have original table, and then we have a table view. So if I run this, it would take some time, depending on your data. It shouldn't take too long, but I've already run it, so we don't have to spend time waiting for it to load, right? So if you run this, naturally, as you can see, this query will process when it runs. So this green tick means that, all right, your query is solid. And also if you have any problems, you can also use the Google Gemini feature, which you can use to create. Sorry, one sec. You can use it to create code. So if you have a problem, tell it, I want to create a model using my AIAS table, right? And we provide the SQL code for it. Right. Once you write this, I'm just going to show you, it will generate the SQL code for you. So, but like I said, you still need to understand what each command is saying, what each variable is trying to accomplish for you to really interact with all these features. So this is basic code to generate a model. Traditionally, we would have written a lot more code to just get our model running. But this is all we're writing now. So like I said, you can just insert the SQL code and it will save it into your script. And then you have something like this, and then you run it. And once you run it, in our data sets, we should have our model view right here. So once I open our model view right here, if we click on model, remember when I said the tables, now we see that we have a model created. This is the model we created. Now if we click on our sales prediction model, We can see information about the model. There's a regression type, the ID, when it was created, location, very important. Then we got the training metrics. Now, because our data wasn't as intense as it should be, or ideally would be, we don't really see this graph come to life. But naturally, it would go from here and go downwards, right? And what that means is because we had only one iteration, if I had done more, you would see the loss go down, basically. And if as your loss is going down, it means your model is getting better at predictions. So you see just one iteration, but like I said, we're keeping it light and simple. Later on in the course, you most likely see a different model that has a lot of the metrics seen. So you also look at the evaluation. Now, this is how we track the errors and we calculate our different errors, right? So you have the mean absolute error, you have your mean squared error, and basically all what they do is they track our metrics. They track what is the difference between our predicted value and the accurate value. They basically all do the same thing, but they're all just tracking different metrics. They're trying to determine what's the difference between our predicted and our actual value, what's the average. So this one does the average, this one does the squared difference. Our mean squared log also tracks the prediction accuracy. The mean absolute error tracks the median difference between our prediction and our actual values. And I'll show you that when we start to make prediction, what it looks like to have predictions and what our actual values should be. The R squared also it explains the variance. It determines how well the model explains variance in the data, right? So how well the model was able to classify the different aspects of the data, sense. So now that we've created our model, we can make inferences. So we can make a prediction and see if, and looking at the values, basically, the lower the value, the better. And that's what it is. For these two, the lower the value, the better. I think for this, the higher, the better. Permit me, I'm not. So now then we'll make predictions about the model, and then we'll make predictions writing basic SQL code. Right now that we know that our model, we've created our model as seen here, we'll make predictions. We'll see if our model is working like it should. Right. So this is when you now come to so right now in our pipeline, our workflow, we've created our model, we've trained our model with our data. We did all that with just that basic line of code, right? With that code, that create model code. So I've created our model, I've trained our model, and I've looked at the evaluation metrics. So we'll check the metrics to see the loss. Is the loss going down? Naturally, it will be going down. I apologize for not showing you that. But naturally, it'll be going down and you see it go down. Then you look at the different values for your different errors and you track them. This is when you now start to talk about hyperparameter tuning. But like I said, a colleague of that will really dive into that later on. And then we'll make inference and see if our model is predicting our values using our test data. So remember when I said we'll split it into training and testing data? Now we'll run our testing data through the model and see if it'll get predictions, if we get the predictions right. We can also look at registering our model. So what that is we'll deploy our model to an endpoint, but we'll look at that when we get to Vortex AI. But I've already registered this model, but when you deploy, so at this stage is when you now come to, you know what, let's make a prediction and then we'll come to the registration. So here we're trying to make a prediction, yeah? And I've already done the script, so we don't have to start again. So this is a basic SQL code for prediction. Again, you have select all from our ML predict is a function, right, in a sense that allows us to make predictions with our model. So we just input the parameters. So machine learning predicts using the model, our AIAS sales prediction model, right? Select the date, store, product number, time series identifier, product ranked from this view. So that the difference now is we're selecting this information from our test view. And what I forgot to show you is we had to create a test view for our test data. Okay, so basically what we're doing is initially we talked about creating a view for main table, and that's when we did this table right here, right? We created this table view. Now we want to create our div import the data. So we need to import our test data, right? So naturally we should do create a table, select upload, select our files. This is our test file. Then our destination, our data set, the name. So we'll call it test view, right? So this is a test table. So this is the original test data before we create a view so we can run it through our model. Auto detect again, so it knows. So this is basically just the 20% of our data set that was left. So we didn't train our model with this. We're going to use it for testing. So once you create the table, that's where we have our AI's test data, right? So now what we're going to do is we're going to create a view for our test data, and this is it here. So this is what we have in our test data, the basic information like we had in our original data, right? And look at the details, insights, lineage, and so on. So now we have our test data. We want to create a view from that test data, right? So using the code we have here, we create the view and then determine where we want to store our view. So that's in our dataset folder. We select all the columns that we want to use to interact with. We perform a little bit of feature engineering so that we have the same columns that we had in our table, our training table. We have the same columns in our test table, right? That's what we're creating the view to do feature engineering, right? And then we say we select that from our original test data, and we order by the store, the product rank and store daily and the date. So when we run this test view, we get this test view for our test data. Now, remember, our model hasn't seen this information before, so it's new to it, right? So it's just going to have to make a prediction. So we'll see if our model gets the right predictions. Does it get the right number sold? I'll show you when we run the prediction, right? So this is our test view. Now let's make a prediction. So now that we've created our view for our test, we will run the predict function or command, and then we select the model we want to use to run this prediction, and then we will determine the features or variables that we need. Our data set, these are the columns are running through, and we're selecting these columns from our test view. Now, if we run this, we'll actually run this. So we'll run this, and then we'll see our prediction. Now, if we look closely at the headings for of the prediction table of the outcome, the result, we have our prediction number. This is what our model predicted. The date, the store, product number, number sold, and the time series identifier product ranking, right? So this is the highest ranking product number 4. And this is the store that sells the highest ranking product, store number 3. This is the date. And this is the number sold of that product, which is 406. And then the time series identifier. So this is basically just a combination of the store number and the product number, and then it's ranked number 1, right? So now we're looking at the predicted value. This is at the 2 columns that really, really are important to us. The predicted number and the number sold, right? So we want to see if our model predicted the right number sold from the actual data, because we're still testing, right? We have not deployed it yet. So if we look at it now, we have negative 275 dot so on, but the actual number is 406. So we're close. Our model is predicting decent numbers. It even predict, but it's negative, right? So there's something wrong. Naturally, it shouldn't have negative value. So it means something is wrong. So this is now at this point that you now say, okay, let's go back to our training. Let's train our model on more data, because I trimmed down the data to make sure that we were able to run the class as smoothly as possible. Usually it would take long depending on the data size, right? So but we're getting our predicted values are far off than our number sold, our actual values, right? Which means our Our model isn't very optimal, it's decent, but it needs more training, more iterations, more monitoring so we can get. But the end goal is to make sure that this predicted number is either 406 or 401 or 402 or 403, 404. And the likes of that. For this positive ones, it's 951, 952. But ideally, you want to be getting 959 precisely, right? This one should be exactly what this is. But what this means is we need to train our model better. It doesn't have enough information to make accurate predictions. And that's where we are. So we could go back and start training again, but unfortunately we won't have that time for that in this class because I still want to cover Vertex AI. So now that we have done this prediction and we're seeing our model make predictions, a model that we created from scratch, cleaned the data, we trained the model, we have evaluated the model, and then we made predictions. Now, let's say, assuming that we got our model was making correct predictions, let's say it was getting 950, 959 or 945, and that's what we're getting here, right? It means that our model is good to go, so we can deploy our model. And so all we need to do that then is to go to our models, right? Registry, and then you register the model. Once you click register, the registration model will pop up and you name it. And you register. So I've already registered this, so there's no need. But this is where the model is located, and this is now when we move it to Vertex AI. So this is what Google Cloud has done. They've allowed us to integrate all these different services into one. So each service is basically talking to the next service. If I do something in BigQuery, I can have access to it in Vertex AI, right? And that's what's happening now. And Vertex AI is like the main hub for all their machine learning software because they've automated almost everything. All right. So now that that's done, I hope we are following. I'll take the questions at the end of the class, but let's just run this up. So now we're moving on to Vortex AI, and this is another service that Google Platform provides. All right. So now we go back to Google, the Google Cloud main sidebar, and then we look for, as you can see, we have BigQuery here. So now we just look for Vortex AI. So in Vortex AI, we'll deploy a foundation model, we'll experiment with some RAG, and then we'll also interact with that foundation model, right? So this is the Vortex AI Studio. But before we get into the studio, let me walk you through the sidebar so you can see what services they provide. I should have done them big L query. All right. So pardon me. All right, so let's look at the services that Vortex AI provides. So they have the dashboard, which is what we're looking at right now. You can use the Vortex AI Studio, Model Garden. They integrate with the Google Colab Enterprise, so you can use Google Colab via this software. You can also prepare your data, feature store. This is where they host a lot of the variables or functions that we use in machine learning. And then there's model deployment. You can deploy your models from model guarding, train them, experiment with them. We'll do RAG. This is where we'll do our RAG setup, and I'll show you how we do that. And then you can deploy them to the registry, and you can deploy them on an endpoint. And when you deploy them to an endpoint, basically what that is you can have an application make requests to this endpoint, and the endpoint will run our model, and our model will reply with the predictions based on the user's query. Right. We can also look at vector search, and this is what I talked about with RAG and semantic search. That's the word. All right. I think the two different things actually. All right. So like I said, we're still looking at the platform. You have the model garden, and this is where you see all the models, the different models that we can interact, foundation models we can interact with. And you can see the different tasks that they are based mostly fine-tuned for, image classification, text generation, image generation, entity extraction, text classification, object detection. But today we'll be using a text generation model, right? But as you can see, there's a lot of models here that they have, the foundation models, all of them. This is the Google models that they generate themselves. So this is a Gemini model. So we'll look at the text generation model, and you can see this is the Anthropic's Claude Sonnet. We have we have uh the Meta Llama, Menstrual Medium, but we're using Gemini today. So we're using the Google Gemini model. So this is the one we'll deploy. So right now what we've done is right now we're working in modern garden, right? So this is Google's modern garden, right? We'll look at the different elements going forward, but this is the model garden. All right. So to interact with this model, we just need to deploy the model. All right. So we'll click Vortex AI, and then this is the name of the model, right? We'll give it a different model name. And again, I've already deployed this model because it takes some time to deploy models. So I'll give it AI AS Gemma model. All right. And then look now, we have, this is why I said pay attention to the location. This is going to create this deployment in East Belgium, right? And if I don't see that now, or if I didn't see that, I'd have ended up looking for my model. But what I'm going to do is I'm going to put this in the US one because that's the one that works best for this model, right? So like I said, different locations, they provide different advantages in a sense. So we'll pick our endpoint name. So once you deploy a model, it deploys it to a model and endpoint. So after this, I'm going to walk you through all the sidebars so we can really understand what we're doing, right? So endpoint name, like I said, is when we deploy our model to an endpoint so that we can make predictions via external applications, right? So we change the endpoint name to AIAS endpoint, right? And then endpoint, and then we click on machine spec. Basically, this is the hardware that we're using to run the model. So you can either pick the NVIDIA or Tesla or any of them, but usually you need to look at locations to see what hardware is available to the location you're picking. The US one usually has all these available, but like I said, we try to pick locations closest to us or the client side. But we'll pick this now just because. So we'll leave that as it is. We'll leave the standard VM provisioning, leave it as standard. How many replicas do we want? So how many model replicas or model deployment do we want? We're going to leave it at one because there's no need to have more than one. If we're going to deploy this for a big system, like a big company system, we could have more than one replica so that if one is working on a particular request, if another request comes in, there is a model available to handle it. So the platform will naturally just run up a different instance of our model and it can answer it, right? So that's what it is. Leave that as it is, and then we deploy. So once we deploy our model, if we go to our model registry all the way down at the end, so deploy and use, we should see our AI gem model deployed. So here we are. Yeah, it's already even deployed to an endpoint. So if I checked our endpoints, because that's what it does, if I check the endpoint, we should see our Gemma endpoint as well, right? So I said before we go further, I'll walk you through basically all the different sidebar elements. So we have the model garden, Vortex AI Studio. We'll come back to that. Gen AI evaluation, you use it to evaluate your models, and then this is hyperparameter tuning and the likes. Here you can design agents, right? And this is their agent guarding. So like the model guarding, you have a guarding for AI agents already created. This is where AI agent is where you can specify the engine behind your agent. And then you have for tools, And then we have for RAG. So we'll look at RAG in a second because that's our next practical. And then you have the Vertex AI search, vector search. But like I said, more on all these other elements later on in the course. We also have our notebooks. So what the notebooks allow us to do is interact with our models in this platform using basic code, right? So instead of naturally we would have deployed the endpoint or integrated our endpoint into an application, our client-side application, right? If we wanted to test our endpoints to see if they were working before we decided to ship them out into the client's website, we can use the Google Colab Enterprise, right? The notebooks. So I'll show you that, how to interact that. Then eventually we'll also look at the feature store, and this is data sets. So what happens here is we can connect our data set in our BigQuery to the one here, right? So naturally, we should see, unless I haven't set that up, but naturally, if we wanted to create a data set, this is how we do it. We just create the data set name. Okay, so we'll need this, but we'll look more into this in the next class, really, when we start looking at auto ML. So we'll look more into that. So we create a data set. We can name it what we want. AIAS, AIAS data set. So this is Vertex AI's data set, but we don't necessarily have to get the CSV file locally. Now we can just get it from BigQuery instead. So we determine the type of data. Is it image data? And this is also important to know that your data, the type of data also influences the type of model. You can't train a model with images unless you want to make classifications. It's just your data basically determines your model, right? Or you can't train your model with any type of data. They need to be correlated. Yeah, your data has to fit the use case of the model in a sense. Right, so you have different types. You can have image, so single label classification, where you're trying to just classify uh a single label for a particular image. So you're trying to say they're all cats, or there's multiple label classifications, cats and dogs, or you want to object detect if you like for all them security cameras, you want to detect people that have face mask and people that don't have face mask. What you do is you load your model with data that you can get from Cargo, really. So if you search for computer vision data, you find data that has images of people wearing mask and not wearing mask. Now, when you design your model, it will train your object detection model to determine if the person is wearing a mask or not, or if there's a car, or if there's a door, or if there's people, those different object detections, right? And then segmentation too. But we're using Tabula today. So we're using our forecasting. But this is also when we look at auto ML. I'm just trying to show you this. But we'll look at this more next week. And then this is Europe for picking our location, and then we'll create our data set. I won't create this now, but I'll create that. You know what? I'll just do it now. So I'll just do it now. And then we'll create this. Yeah, so this is why you try to do everything beforehand. All right, no, I'll just leave it at this. Let's move on to, while it works, move on to the next thing. So what I was trying to show was that once this data set was created, we could import our table from BigQuery and not have to do it locally. That's the level of integration that AI Google Platform has. And then here we can see what models are training, if we've set up any training jobs. And again, we'll look at that more next week. We can experiment. And then metadata, so we track our metadata. And then here we look at the models registry, the endpoints, batch inference, and then we monitor. Right, so you need to set up the whole monitoring configuration. This is where we start to look at model pipelines, and Vertex AI allows us to automate the entire pipeline. And what I mean by that is, so let's say we have finished our entire workflow end to end, and we have deployed our model to an endpoint, right? Now, if we decided to train our model on new data, we wouldn't have to start from scratch again and start writing the queries or have to, start from deploying the model, then fine-tuning that model. All we need to do is create a pipeline and automate that pipeline. So we're going to automate the entire machine learning pipeline, and you should see that more later on in the course. So I just thought you should see what that is now. So now that we've looked at the sidebar, we're going to interact with our deployed model. So we go to our here model endpoint. We'll find our model. All right. Then we see this is our model. So this is the model endpoint. Now to interact with our model, we're going to need this information. So the model endpoint, the region, and so on, right? And what we're going to do is we're going to open the Google Colab Enterprise, right? And again, I've prepared our notebooks ahead, so we just need to understand what's going on. All right, so this is not it. All right, so we have our model deploy test. So we've deployed our model, right? We deployed our Gemini model. You can deploy any other model, right? But usually all of them have their different. I think sometimes you can interact with the model via the AI Studio, and I'll show you that. But we're deploying a model now. So for when you're trying to interact or with your model you're deployed, so this is the script that we'll use. For Python, you have to install your dependencies first. So for this one, we need to install the Google Cloud AI platform, which is Vortex AI's platform. And then we import our dependencies. So from from Google Cloud, import AI platform, and then we determine our project ID. I'm going to zoom this in so we can really see this. So from Google, then we'll identify or set our project ID. And then you can find this from the Google query dashboard, right? So you can see the project information. Let me show you that real quick then. All right. So this is where we'll find our project information. Uh, no problem. So it's all the way here. Here we go. Cloud overview. So now we see our project. So it's still on the main Google Cloud platform. So you see our project name, project number, project ID, the API calls we've made. Basically, I should have showed you this as well, but I'm sure we'll get familiar with it. So this is dashboard for our project, the resources that were available to us, uh, basic get started, we track our API calls. So back to our inference, right? So we're trying to interact with our model that we deployed. So we have to set our project ID that we got from our dashboard, the region, right? So our region is global for the project, but we specify because this is where the model is deployed, right? So naturally, yeah, so we just specify the regions where the model is deployed. This is the model endpoint, and this is where you see when you look at the information on our model before. So then you initialize the client, add platform, initialize project ID, set the parameters, location, and then your endpoint is your AI platform endpoint name, project ID, location, endpoint ID, and then your instance. This is now where we talk about the prompt. So we could say, write a short poem about a sunny day, or let's say, uh, find ML in the query, right? So this is a prompt. So we're defining our prompts, and then we create our response. So our response is our endpoint.predict function instances. So we're trying to, this is the, well, this is our instance that we are trying to respond. We want our model to respond to. So then you print your generated text for predictions and so on. So I'm going to print this. So I have to run this. Okay, so I need to actually walk you through briefly the Google platform. So if you haven't used Google Platform before, Google Colab before, it's a service that allows us to run basic Python script without having to worry a lot about the environment and some of them even have your dependencies already installed in them. Right, so you don't really have to look too deep. The tensor or like so for machine learning now we use skitlearn or PyTorch for deep learning and TensorFlow, right? Most of all those frameworks are already installed in Google Colab, and that's what the Google Colab Vertex AI instance gives us. It gives us already installed scripts with notebooks with all the frameworks that we need already installed. So we just need to write our code to interact. So you can write your code. This is the run all button if you want to run all the cells, but this is the button to run just the cell that you are currently in. So all these are cells. So this is one cell, this is another cell, there's another cell. I can add another cell here. Is a code cell or a text cell? You want an XUS, SUS cell? So it's very diverse. It gives us a lot of things, right? So you can save. And then we need to look, another thing you need to pay attention to is your runtime. Your runtime basically determines what hardware you're running your notebook on. Now, if you're doing intense model training, it's best to always use a GPU or a TPU because they can handle the training process. But if you use a CPU, you wouldn't really, get the fizzy of your interactions in a sense, right? It would take too long to train your model and it would just take a lot of time. So it's best to always use GPUs and you can select what runtime you use up here, right? So you can connect to a runtime. Uh, one sec. None of sessions not active. Let's try and connect to a runtime, right? So once we connect, we should be able to start running all the different elements of our cells. But I've explained what this code basically is. We're just trying to, prompt our model. If we had time, we could design an entire UI just to interact. But this is a backend direct way to interact with your model, right? So once this says we're connected, I can start running our cells and we can see our model respond to us based on our query. All right, you know what? All right, so this is taking some time. Aha, there we go. All right. So it's loading and trying to connect us to the appropriate, hardware that we'll need to run our scripts. So there we go. So we can change our runtime, I think. If we wanted to use a different, because this is the only one. This is the only one. But if we wanted to use a different hardware, we can change it and all that. Anyways. That's on me. I should just continue. All right, so while this loads, I think we just come back to this so it doesn't waste any more of our time. I'll just open the Vortex AI Studio in a different tab, and then we'll interact with that. And I'll show you what RAG is and how it works. Lucky us. So now we're running on a hardware. I'm not going to interact with this so it doesn't delay us anymore. So I'm going to run our first script, which is to install our dependencies. And as you can see, they've already been satisfied. So because I've run this before, all the dependencies that we need to run the script are already there. Right? And this is why you need to understand the language if you're going to go forward. And then we'll run our script and see what our response will be. So while this is happening, when our script is talking to our model that we deployed on that endpoint, and we'll see how it responds to it. All right. We could have added more parameters, but let's see. So prompt, define ML in BigQuery, output. ML is a hardware processing framework designed to enable efficient large-scale machine learning. So this is a basic definition, and it works. If we wanted to add, we could add more max tokens and all that, more parameters, so we had more content. But I think this shows the point that we've deployed a model without having to write any code. We just picked the model from Vortex Studio, sorry, from Model Garden, deployed the model, and we're talking to it now, right? So now we're going to go on to using RAG. I'm going to go on to using RAG in Vortex AI Studio. Now, like I said, RAG is basically just augmenting your model with your company's data. And for this exercise, I'll be using my company's question and answer pairs, and then we'll see how the model responds with RAG and without RAG. So, but first for RAG, we need to download our I'll be done. This is the last our last exercise for today. So once I'm done with this, we're done. Hopefully I should make it before 1:30. Okay, so we'll start with RAG. And then for us, what we need to do is create a corpus. And what that is just a fancy name for knowledge base. It's a group of documents that are used for RAG in a sense. So we create a corpus, right? Select the location, corpus name, description. So it could be AI corpus, describe it, and then we upload it from our local file. Now, RAG doesn't do CSV format, so we need to upload a text format, and this is what it is, Q and A pairs. So we upload this, and we click continue. We click continue, and then we configure. So this is, like I said, I mentioned embeddings, right? So this is basically what embedding model we're going to use because there are models that created just to create embeddings. So models that their only job is to take text and convert it into numbers, right? So our systems can process the numbers better. So we select the model we want to use. We use the embedding text multilingual embedding 002. And then that's it. And we create our corpus, right? So once we create our corpus, we should get your corpus created here. Now, once you open that corpus, you should see the text that you uploaded. If you don't, you can always import more. So, like I said, it is a knowledge base for all your different data. So you can import it here if you don't see it there, and you can import it again. But we're not going to do that because we already have that. So here now we have our corpus and we have our RAG database setup, our RAG database setup. Now let's go and interact with a model in Vertex AI Studio. Right, so we're going to pick a model and we're going to implement RAG and see how it answers with or without RAG. So tick chat. So if you look on the right, we have our basic information and then we have our model settings. So this is the model we're using. So we're just interacting with the foundation model as it is. Its thinking level is high. But then now we look at the outputs and the grounding data. So if you can see right here, it says Google grounding on Google search. So if I query this model right now, right? What is PSC, right? This is my company. But it's grounded on Google data, right? So if I query it right now, we should see some generic response. Put this in. Okay. So as you can see, it says PSC is an abbreviation that stands for several different things depending on the context, business and finance, Philippine Stock Exchange. This is generic information. It's not wrong, but it's just trying to give you abbreviations, but it doesn't know. So now let's add RAG. Let's implement RAG and see how the model responds then, right? So we'll toggle this off because you're only allowed to use one, and we'll do grounding out your data. So we're going to do RAG engine, Vertex AI search, or Elasticsearch. We're going to use RAG engine, right? So we'll click on RAG engine. And if we're lucky, we should see our RAG corpus pop up, right? And top K is just the top K similarity. So we want to make sure we're getting the best out of our search. We can also look at this, but it's not important right now. So we'll save this, right? We can modify the temperature. That just affects the deterministic nature of the response, but more on that later. So now we want to see if our model will respond better with our uh, with our company data attached to it. And there we go. So based on provided sources, PSC, Panoramic Synergy Enterprise, and IT consulting and professional service company. They specialize in providing information technology solutions, IT governance, risk compliance, ARP deployment, digital transformation, and artificial intelligence services. So as you can see, our grounding data is our Q&A pairs. So with that, I've been able to show you how RAG works, and you can see the difference between same prompt, but different database and different results. So if I went on and prompted it some more, it would have all the information from our knowledge base right here. So with that being said, we have covered today, we have discussed foundation models, we've talked about machine learning, we've talked about, well, not in detail, but we talked about BigQuery machine learning, talked about vector AI, talked about RAG, the machine learning life cycle, and how to implement that. So with that being said, I'll stop sharing my slide, and we have come to the end of the class. Uh,
Okay, all right. Thank you very much, Mufe. Please let's begin to show our appreciation to our trainer in the chat box, or you can unmute your microphone and also tell our trainer a very big thank you. I was very, very busy, but I couldn't help but be intrigued by what our trainer was going through. So please let's express our appreciation to our trainer. And are there any questions, please? Do we have any questions?
Thank you so much. Thank you, Mr.
Okay.
Mufe. But me, I want to say that we are novice to this AI class, and I want to plead that it was a bit fast. So some of us couldn't catch everything he was saying. That's just the problem. But what he was saying was quite important. I think I have to go back and watch it over and over again to be able to catch everything. But he was quite
Definitely,
fast.
ma'am.
But thank you so
Definitely,
much.
ma'am. The recording will be made available as soon as possible.
I will try to be slower going forward in all the other classes.
Beautiful, beautiful. That'll be appreciated. Okay, so moving forward, if there are no more questions, okay, seems there's a message in the chat box. Okay, someone is just thanking you once again from Kehinde Alabis. Thanking you very much. All right. Have you filled the attendance? Please ensure we fill the attendance before you go. I will be sharing the attendance and the feedback form in the group shortly. Please ensure you fill that up before we go. And I would like to remind us that the assignment and the materials for this class will be shared immediately this class ends in the group, so you can go on straight ahead and do your assignments. Without any further ado, I would like to let us go. Thank you very much for joining us in class today. The program will continue, of course, on next week Friday, and we look forward to seeing you in class. I have shared the feedback link and the attendance links in the group, in the chat rather. Please endeavor to fill them out before you leave. Please enjoy the rest of your weekend and see you next week in class.
Thank you all. Have a good weekend.
You too.